Hello everyone, my name is Deena and today I will be presenting my project on electronic voting machines, commonly known as EVMs, viewed through the lens of embedded system design. Let's get started. EVMs. So exactly what is an EVM? An electronic voting machine is an electronic device that records votes digitally, completely replacing the need for traditional paper ballots. And its core, it combines both hardware and software components to serve one dedicated purpose, secure and accurate voting. This is what makes it perfect example of an embedded system. Now, let's talk about why EVMs. Now, why do we use EVM in the first place? There are several compelling reasons. First, they eliminate the need for paper ballots, making elections more eco-friendly. Second, they minimize human errors that are common while manually counting. Then third, they enable instant vote tallying and gives us results much faster. And importantly, EVMs prevent fraud by blocking invalid votes and streamlining the entire election process. Now, let's and look at how an EVM is structured. An EVM consists of two main units, the control unit and the ballot unit, connected together via a secure cable. The control unit manages the overall voting process, while the ballot unit is where the voter actually casts their votes. These two units work in tandem to record and store the votes securely. Now, let me walk you through the key components inside an EVM. Now, the microcontroller. The microcontroller is the brain of the system. It processes all the logic. Push buttons. Push buttons allow the voters to make their selection. LED indicators. LED indicators provide visual feedback, while a buzzer gives audio confirmation of a successful vote. Memory unit. A memory unit securely stores all cache votes, and the entire system runs on a battery operated power supply, making it portable and independent of mains electricity. Working principles. Now let's understand how the EVM actually works step by step. First, the voter presses the button corresponding to their chosen candidate. Second, the microcontroller immediately locks that vote. Third, the LED lights up and the buzzer beeps to confirm the action. Fourth, the vote is saved securely in the memory. Fifth step, and this is the crucial step. The system allows only one vote per voter, preventing any duplicate voting, and it's simple, fast, and secure. Get better understanding of the embedded system concept. Let me give you a classical example. That is, it is a single purpose device with a dedicated function. It is microcontroller based, meaning all processing happens on a chip. It operates in real time, responding instantly to voter input, and it features a tight hardware software integration. The software is specifically designed for the hardware it runs on. These are the defining characteristics of any embedded system. So basically now we have talked about embedded system concept using the electronic voting machine. Since we have talked about the embedded system concept, let's see what are the advantages of this concept. Like let's talk about the advantages. Like any technology, EVMs have both strengths and limitations. On the advantages side, they offer the fast counting with instant results, high accuracy, and with minimal errors. They are paperless, eco-friendly, portable, and cost-effective in the longer run. Since we have talked about the advantages parts, let's quickly go through its limitations. So, however, there are some limitations to consider. EVM requires skilled technicians for maintenance. If not properly secure, there are potential tampering concerns. They depend on batteries for power, and there are ongoing public trust and transparency issues in some regions, which is why the robust security protocols are critical. Now, let's look on to the applications. EVMs are widely used across different contexts, most notably in national elections for countrywide voting. They are also used in student body elections in colleges and schools and for organizational voting like corporate decision making. This design is scalable, whether it is a class of 30 or a country of millions. To conclude, electronic voting machines significantly improve the efficiency, accuracy, and reliability of elections. As an embedded system, the EVM is a brilliant real-world example of how hardware and software can come together to solve a real-life scenario problem. The principles we see here are dedicated function, real-time response, and secure data storage are the heart of embedded system engineering. Thank you so much for watching. I hope this presentation gave you a clear understanding of EVMs and their place in embedded system design.